Guys, I'm back with example 3 in the challenge problem section. So guys, this is, again, it looks like an exponential function, but it is much simpler than the other two examples that we have seen in this challenge problem section. Guys, you can see that it is 2 to the power x squared. So of course there's two exponents going on here, but here the base is still a constant. Guys, there's two ways of actually working through this problem. One is which we already know, like how to find the derivative of functions of the form of the exponential functions of the form b to the power x. So the derivative of something of the b to the power x form is just b to the power x times ln of b. But then if we have something more going on with the exponent, then we have to multiply by the derivative of that inner or that exponent, which is basically using the chain rule. So guys, that is one of the ways to actually do this. So it is not too complicated to use that method. Guys, the other way is still using the method that I have been using for the other two challenge problems, which is applying logs to both sides. So guys, for this particular example, I'm going to illustrate both the methods so that you can see like there's more than one ways of doing it, and then you decide which method you want to use. So method one, guys, let me apply the log on both sides as we have been doing in other problems like this. So if I apply log on both sides, it's going to be ln of y and then ln of 2 to the power x squared. But we already know that we can use the power rule of the logs here. So how is that going to look like? It's going to look like x squared times ln of 2, because you just bring the whole exponent up front and then you multiply by whatever is left here, ln of 2. So guys, once I have it simplified, I just ignore this. Now I I take the derivative on both sides. Taking the derivative of this is just 1 over y times y prime. Okay, we have been doing it for some time, so I'm skipping that step. And taking the derivative of this, guys, keep in mind ln of 2 is just a constant, right? So I just have to write the derivative of x squared, which is 2x, and I have to just write the ln of 2 because that's what we do. We don't do anything with the constants when they are multiplied with the variables. We just take them outside the derivative and then we just find the derivative of the variable piece, which is 2x times this. Now getting y prime by itself simply means you got to multiply both sides by y. If I multiply both sides by y, the y's cross out, I get y prime, which is what we want to evaluate, is y times this whole thing. But what is my y? It's 2 to the power, so it's 2 to the power x squared times, then I can write this as 2x and ln of 2. Guys, that would be one of the ways of evaluating this. The second method is like a right-away method, straight-away method, using this formula for the derivative of an exponential of the form b to the power x, and then also applying the idea of the chain rule. So using that method, guys, this guy is going to be the derivative, y prime is going to be, this is my b to the power x. So it's the derivative of an exponential function of the form b to the power x is the exponential function itself. That is the beauty of these exponential functions. So it's 2 to the power x squared by itself, but you have to multiply by the ln of the base, and base here is 2, and in this case we're allowed to use that because base is a constant. Guys, keep in mind, if I have a variable base of any type, I cannot use this direct formula right away. That's why we had to apply the logs in other two challenge examples that I did before this one. And then we still have to multiply by the derivative of the inner, and in this case, guys, keep in mind the inner is just this x squared, and what is the derivative of x squared? It's just simply 2x. So you can rearrange this, 2x squared, and then this is 2x ln of 2. It exactly is the same thing that we obtained from this method. So guys, I mean, if you can directly see that this is an exponential of the form b to the power x, just use that method. Or if you are like, sometimes when we are doing these things on a test or a standardized test or a test where you have to solve 15 different problems in an hour or 2 hours, guys, sometimes we cannot think about like very simple methods. Then if you remember another method, then you can also apply that method. That's why I actually wanted to show you both methods for this case, okay? And guys, I mean, if you are able to find other easier, simpler, other methods for other problems that I have been trying to do, please feel free to try those, and then please share them back with me because guys, it's not like you're trying to learn from me. I'm also trying to learn from my students, and which I do all the time. So guys, feel free to do that as well. So this is example 3. I will see you next time with another example. Till then, guys, take care.